Hi, good morning. Welcome back. So in this video, I'm going to show you how to identify or describe a vertical translation, okay, and also graph the transformation of that has been applied to the parent function on x or y in coordinate grid. So how would you identify a vertical translation? Okay, the way you will identify a vertical translation is when you see a number. Let's say you have a parent function which is 1 over x. Okay, so you have a parent 1 over x. You see the ratio 1 over x or the fraction 1 over x. Okay, you're going to see a number added or subtracted. So I'm going to use plus k here. Okay, so I see there's a number being added to the parent function, the y value of the parent function. So that's why you have a vertical shift. So you see here it's a vertical translation, and the direction of the vertical translation is up k units. And remember, k represents a number. Okay, so this is when the direction is the parent function has been moved up. So now the other example we have is when you have 1 over x minus k. And what does it imply? So because you're minusing from the parent function, the y value of the parent function, you're minusing the number. So you're going down. So the parent function has been shifted down. How many units? You see your k unit. Okay. So now you're going to graph. So let's do some example of vertical translation. Okay, so for number 1, I asked you to describe the transformation, then graph g of x using the parent function f of x equal 1 over x. So first, let's describe the transformation. What kind of transformation has been applied to the parent function 1 over x? So here I see that a number is being subtracted away from the fraction, okay, from the rational expression 1 over x. So what does it imply? Okay, so it implies that if you have a vertical translation, the transformation is a vertical translation. And remember, when you see a number in the denominator being applied, a number being added or subtracted to the x, that's when you refer to horizontal translation. Here, it's a vertical translation, and the parent function has been shifted down, and you say 2 units. Okay, so down 2 units. So let's then graph. So you're going to graph the parent function first. Okay, and for the y and the x-axis, I'm going to use for 2 units to represent 1 unit. So that's what I'm going to do on both the y-axis and the x-axis. 2 square represent 1 unit. Okay, so remember from last video, I have the order pair from the parent function. So both order pair I'm going to use to graph the parent function. Okay, so I plot the points, so now I'm connecting them. And make sure that we have a horizontal asymptote and the vertical asymptote. Make sure that the rational function is going to approach on the asymptote. So you want to connect the dot. So make sure that horizontal you connect the dot, and then make sure the vertical, the rational function approaches on the asymptote, but never crossing them over. Include the arrows at the end. And that's the parent function f of x. Okay, so now I'm going to use another color, and I'm going to represent g of x. So what is happening? From the y value of the parent function 1 over x, I'm minusing 2 each time. So this y value is, let me write, it's negative 4 comma negative 0.25. So I have to minus 2 from negative 0.25. So negative 2, so negative 0.25 minus 2 is going to be negative 2.25, which is about right here. This is negative 1, negative 2, negative 1.25 is right. Negative 2.25 is right here. So you're going down 2 units each time. So I take this order pair. This one is exact, so all I have to do is to count 2 units. But because I'm using 2 square to represent 1 unit, so I have to use 4 square to represent 2 units. So this is 1, and then 2. I place my point. Okay. So you go down 1 and 2. Okay, this is 1. Okay, and then 2 goes right here. So 1 and 2 goes right here. So now this other pair, this point is 4, positive 0.25. So from positive 0.25, I need to minus 2, which is going to be negative 1.75. And negative 1 is right here. Negative 1.5 is right here. Negative 1.75 is right here. So I'm going to place my dot. Okay, so now I'm done placing the new order pair. Then I'm going to identify, because the parent function has been shifted down 2 units. Okay, I know this is used to be the horizontal translation, y equals 0. Now the parent function has been shifted down 2 units. So the horizontal translation has been shifted down as well. Okay, and I hope you can notice here that this number right here, the number away, the negative 2, represent as well the horizontal asymptote, which is going to be y equal negative 2. Okay. So the new horizontal asymptote, okay, I'm going to take it's going to be a y equal negative 2, a horizontal line that cut the y-axis at negative 2. Negative 2 is right here. So I'm going to use my ruler and I'm going to draw a line. I'm going to use a dashed line to represent the horizontal asymptote, which is y equal negative 2. Now, what is the vertical asymptote? So it's going to take the denominator and you set it equal to 0. So x equal to 0. So it remains the same. Nothing has been shifted to the left or to the right. So you still have the same horizontal asymptote, vertical asymptote at x equals 0. So what I'm going to do next, I'm going to use another color. Okay, then you're going to connect the dots. So as you connect the dots, you have to make sure that the rational function is approaching on the horizontal asymptote. Oh, I skipped this one right here. So you have to go down 1, 2. Okay, so next let's do the right piece. So approach it on the asymptote but never crossing it over. You connect the dot. And voila. And the one in black represents the function g of x. Okay, and we are done graphing number 1. Okay, so now for you to check your understanding and to practice, okay, I would like you to do number 2. Okay, I'm going to call that h of x equal 1 over x plus 2. Okay, describe the transformation and graph h of x using the parent function f of x equal 1 over x. So please pause the video and do that on your own. Okay, so you can tell here the number is being added is now plus 2. Okay, so it's away from the fraction, which is vertical translation, and the parent function has been moved up 2 units. Okay, so then what do we do next here? So next, I use the same order pair listed, the same order pair. You can pause the video. I use the same order pair right here for the parent function, and I plot them on my x and y coordinate grid. Okay. So now, just ignore the. it's upside down. That's okay. So, okay, so now you're going to go up 2 units each time. So this point here is going to shift 2 units. So I'm going to go up by using 4 squares because I use 2 units represent, 2 squares represent 1 unit. So this one is 0.25 plus 2 is going to be 2.25. This is 1, 2, and 2.25 is right here. Okay, so I'm going to do the same on the other side. I'm going up 2. And this one is negative 0.25 plus 2 is going to be positive 175. So this is 150, positive 175 is right here. So now the horizontal asymptote is going to be this number here. It's going to be y equal positive 2. So my horizontal line has been shifted up 2 units. Instead of being at the origin, it's going to go up 2 units, which is right here. This is the line y equal 2. Okay, so now I'm going to use maybe the red one again, and I'm going to connect and make sure the rational functions are pushing on the asymptotes, but never crossing them over. Remember, the vertical asymptote remain the same. Okay, we don't have any horizontal shift, so it's going to be x equals 0. I'm going to do the same. I push on the asymptotes by never crossing them over. And that's the function h of x. Okay, so I hope this video was beneficial to you and you were able to learn a lot. Okay, so thank you for watching my video. Okay, so this video was an example of describing and graphing the vertical translation. Okay. So thank you. Have a nice day. Bye-bye.